Okay, you guys are now ready to start Chapter 8. Section 8.1 involves something a little different. It's talking about inverse and joint variation. It's a relationship between two equations. You guys are used to seeing equations like this. Y equals some number, we're going to call that A, times x. That's called direct variation, when two numbers are multiplied together like that. We're going to talk about inverse variation, and you'll see the equation in just a second. Your I can statement for this one is I can use inverse and joint variation models. Okay, here is the equation. Two variables, x and y, show inverse variation if they are related like this. And it has to look like this. It should be in the form of y equals the constant of variation, A, divided by x. If you have an equation that looks like that, with y, a number divided by x, then you have inverse variation. So what we want to do here is we want to take our equations and we want to rewrite them to see if we have inverse or direct variation. Remember, for either variation, we want them equal to y. So we're going to take our first one here. We have to solve for y, because that'll show us inverse or direct variation. Solve for y, I got to divide out x. That cancels on that side. My new equation, 7 divided by x. And that is inverse variation, because it follows our definition. Our definition says if it looks like that, it's inverse variation. This is the definition. It's got to be y equals some number, the constant of variation, in this case 7, divided by x. Let's check this one. Well, this one's already y equals, and it doesn't look like that. It has x plus 3. It does not look like inverse. The other one that we talked about on the first slide was direct variation, where it's y equals some number times x. Well, we don't have that either. So we don't have to rewrite it because it's already y equals, and we say neither. Now our last one here kind of looks like inverse variation a little bit, but you'll notice it's equal to x. We don't want that. We want it equal to y. So we have to cancel out this 4 and put it on the other side. Y divided by 4, I have to do the opposite of that to cancel it. I'm going to multiply both sides by 4. That's going to cancel. I am left with y equals x times 4, which is the same as 4x. Look at that. I have a constant, some number, times x equal to y. That looks like my direct variation. So when you do problems like this, all you're doing is solving for y and seeing what it looks like. That's it. Okay, now what's going to happen is we want to write the variation equation. Okay, it tells me two variables, x and y, vary inversely. So the word inversely means I want this equation, and y equals 7 when x equals 4. Write an equation that relates x and y. Then, and we're going to stop right now because that's a second step. We've got to write our equation first. So it tells me, I'm just going to do what it says. Y is 7. I don't know a, they don't tell me a, and x is 4. So what I want to do, my equation should look like this, where I have a y and an x and a constant of variation a. I don't have that yet, so I have to solve for a. I'm going to get rid of 4 on this side. A divided by 4, I do the opposite to cancel it, multiply by 4. This is going to cancel. I am left with 28 equals A. Okay? So now we're going to take that constant of variation and put it back into my equation, because they wanted me to write an equation that relates x and y. So I'm going to say y equals 28 over x. That's my inverse variation equation. Now I'm ready for step 2. Step 2 says they want me to find y when x is negative 2. I think you guys probably know what we want to do here. We're going to take this x, plug it into that equation, and figure out y. So we're going to go y equals 28 divided by negative 2. So x is going to be negative 14, and it's not x, of course. It's obviously y. You can see I just wrote the wrong variable there. So we divide, we get our final answer for part 2, y equals negative 14.